Okay, so for our last question, we're gonna find all the critical points we need to graph this equation. And our function is 1 over 1 minus cos x. And our interval is between 0 and 2 pi. So the first thing we're going to do is find the vertical asymptote. The way we're going to find this is we're going to equal the denominator to 0. So when we do that, we're going to get cos x equals 1. And cosine is 1 at 0 and 2 pi. And because our intervals are closed, we can include those. So next thing we got to do is we got to find the x-intercepts. So to find the x-intercepts, we're going to have y be 0, and then we're going to solve for x. So it's the same idea. We're going to multiply the top and bottom times 1 plus cos x. So we're going to get 0 equals 1 plus cos x, and then negative 1 equals cos x. So when cosine equals negative 1, it's at pi, and pi is in our interval, so we can use that. Then for our y-intercept, we have to do the opposite. So we're solving for y, so we're going to make x equals 0. So to do that, we're going to multiply top and bottom, or actually we don't need to do that. We plug in, where's cos 0 at pi over 2? So we plug that in, and then from there, then we multiply 1 plus pi over 2 to both sides, or to the top and the bottom, then we get 1 plus pi over 2 equals 1. And then we get pi over 2 equals 0, which doesn't exist, so we do not have a y-intercept. For the next part, we're going to take the first derivative of this. So we're going to do the low d high, so 1 minus cos x times 0, minus high d low, so 0 minus sine x, all over low squared. So this is just going to turn into 0 because anything times 0 is 0. And then if we distribute the 1, we're going to get 0 plus sine x all over 1 minus cos x. So when we simplify the top, the zeros will just cancel, and what we're left with is sine x over 1 minus cos x to the second power. So that's our first derivative. So next we're supposed to find the critical numbers. So the way we're going to do that is we're going to set the top equal to 0 and the bottom equal to undefined. So the top, when it's equal to 0, we're going to get x to be 0 and pi. We can include those because it's in the interval. When we set the bottom equal to undefined, we're going to get x to be pi. So our critical points are going to be 0 and pi. So those are our critical points. Next, we need to find the second derivative. So our second derivative, so this is our first derivative that we have to find the derivative of. So we're going to do all these ones. We're going to do low d high minus high d low, which is just, we're doing the chain rule for this part, all over low squared. So that's our first step. Second step, we're going to combine a few terms. So we foiled this. So that's what we're going to get when we FOIL it, times cos x. And then we distributed this on the top, so we're going to get 2 sine x times 1 plus cos x all over 1 minus cos x to the 4th. So we're going to distribute this cos x and get 2 cos squared x plus 2 cos cubed x minus, and then we're going to distribute this as well, and we're going to get 2 sine x plus 2 sine x cos x all over 1 minus cos x to the 4th. So what did we do here? Okay, so this is going to change because it's a trig identity to 2 sine x. And then from there, we're going to combine it all. So this is going to change to 2 sine x, so these two are going to cancel. So all we're left with is 2 cos squared x plus cos cubed x all over 1 plus cos x to the 4th. And that's going to be our second derivative of the function. So then we're going to find the point of inflection. So we're going to equal the top to 0 and the bottom to 0. So when we equal the top to 0, we're going to take out a cos squared x, And then when we do that, we're going to have x equals pi over 2 and 3 pi over 2. And then when we do the other part equal to 0, we're going to get cos squared x equals negative 2, and that doesn't equal anything. That you can't solve for that, so that's going to be the end of that problem. And that's it.